So I have kind of two purposes for this video. One is I want to update everybody and get everybody's feedback on what we're doing at ATIA with the Xbox stuff, with the Magic Wheelchair, all that good stuff. And probably the other is that I've got all these Xbox controllers that are now kind of sort of done. And I want to walk through them and show how they work. Some of them are going to be in the Microsoft booth. Some of them are going to be at the Grip booth. Some might be at the Lesson Picks booth, I'm not sure, but they're all worth seeing. All of them take one of the approaches we've used or an idea we've had in our group, combines them with the XAC, the Xbox Adaptive Controller, and makes something that really allows gaming or control of a gamepad on a PC for somebody who might otherwise not be able to do so. Okay? So this is the first thing I want to show. If you guys have seen things over the past couple weeks, you might have seen me show something that looks kind of like this before, but this is now beautiful, which is awesome. This is a tank control for the Xbox, and I'll kind of show how it works, but I also want to show kind of some details on it as well. The idea here is as you move these forward and back, you get tank controls. You get forward, reverse, turn left, turn right, and it basically gives you the ability to. Let me do this. Obviously came from Carl Sigman as the inspiration for this. His device that he uses to communicate follows this approach, and that's where the inspiration came from. And I got to thank him for that. I do have a little bio that we put with every one of these. That has a little write-up of who inspired it, and then kind of explains how to use it. So, all right, so this shows the Xbox tank controller, and on the left-hand side there you'll see Rocket League, which is a popular game nowadays. And I'm not sure I'm going to be able to score, but I'll at least show you how this works. You'll see when I lift these up, it becomes active. If it's all the way down, it defaults to just being off. When I move forward, you'll see the car will move forward. When I move back, it moves back. And if I use if I push one farther than the other, I'll be able to steer. So I need to turn around because the ball's behind me. So I'll go forward and then turn. There's the ball. Oh, so I never said I was good at this game. Let's try this again. There you go. That might actually go in. It is going to go in. Very good. That was easy. All right. So that kind of shows you the idea here. I'm using only gross motor abilities to drive the car. Probably the most important thing about this is that it is inexpensive. I chose to put it on a beautiful. I chose to put it on a beautiful piece of wood. My friends at Maker Effects. Let me stop that. There you go. My friends at Maker Effects Makerspace in Orlando helped me laser etch our logo into this, so it's beautiful. Absolutely turned out stunning. Couldn't be any happier with that. In fact, it makes me really want a laser cutter. But probably from a technical standpoint, the most important thing here is that it runs off of a trinket. So a trinket is a little Adafruit chip, costs $8, and here you'll see it's basically just got 4 wires coming into this device. Basically power and ground go out to each of 2 potentiometers, 2 volume controls. And then the data comes back in these 2 yellow wires. The chip then reads that and does a little bit of math to convert the forward and back of left and right into the joystick coordinates. Okay, the source code will be available. I did put a little Xbox in there. I hope they don't mind. It's going in the Microsoft booth. I figure they'll be good with it. The other important thing to show you is this. So this is actually the end of one of the knobs, and you'll see it's got I don't know if you can see this. It's got a potentiometer in there, a volume control, a variable input control, and basically what's neat about this is it has this foot. And this foot is kind of neat because it's not mounted to the wood at all. And so if this moves around a lot, it's okay, right? If it wobbles and it is pushed around, it will always catch again. So that's kind of how we left enough wobble in here so that there wouldn't be any resistance. And if it was roughed up a little bit, I wouldn't be pulling the things off of the board. So I kind of like that. Everything else here is pretty straightforward. Let me darken that a little bit. So here you'll see we took it into a tennis shop and had them put Gamma tennis grips on it. So it's nice and easy to grab onto. And I think it looks great. We spray painted everything. We kind of went to town on this one just so that we could kind of show, you know, the fact that something is homemade doesn't necessarily mean that it's ugly or stupid or falling apart or not going to be able to support it. It can be awesome and still be maker made or homemade. And we think this one's gorgeous. I think this one's gorgeous. So Lori did a ton of work. Lori, my wife, Lori Binko, and I did a ton of work on this one, and we're really, really happy about it. So, all right. So these glasses we showed earlier as well. Kind of give a close-up of these. So this is just a pair of sunglasses. I have lots of scratched-up sunglasses. I live in Florida. I pulled out the lenses, and I put on the side a Itsy Bitsy M4, which is a $15 chip from Adafruit, basically a microcontroller with lots of inputs. Don't need much of the inputs. And then I put a what's called a BNO 055. It is a absolute orientation sensor. Basically, it can tell which way is up and whether you've turned left or right. So it's got a combination of an accelerometer, a compass, and a gyroscope in there, all on that one little chip. And we mounted it horizontally with the frame of the glasses so that when you wear it, and I will do so, it can track where your head is looking. So you'll see here I'm able to just look around, and I'm flying right now, but that's how the game works, right? That's not really me so much. There you go. So I can look left and I'm walking around. So this is a great way to control things if you only have head movement. And again, it was not a significant cost. Let me go through the costs on this guy. So the costs on this are about $15 for this chip. $15 for this chip right here, the Itsy Bitsy. I think you probably could do it with a trinket, which is about $8. And then this one is about $30. I think it's about $30, which is probably the most expensive chip we have that I use on any of these projects. But it's really nice. It does all the math for you. It gives you the orientation directly, and it gives you every possible direction that you want to control. So this is probably a $50 project, plus the old pair of glasses. All right, this one doesn't actually use a microcontroller at all or any special parts. What it does use is a tiny thumbstick. So this is a tiny thumbstick that I bought for, I think, about $6. And then I 3D printed an enclosure. There's nothing other than this thumbstick wired to a 4-conductor aux cord. So here's the other end of the aux cord. Right? So this is really all this is a thumbstick wired to a 4-conductor aux cord. And it turns out that if you plug that into right here, the X1 or Y or X1 or X2, that makes this the joystick for this controller. So, all right, so let's go ahead and see if we can't score easily here. I had to ruin it, didn't I? There you go. All right, this one's a little bit different. Instead of only using gross motor, this only uses fine motor. So this one literally is about as small as I think you can get a joystick. I would probably make a InstaMorph grip that fits somebody's hand and place that right there for them. Or mount it someplace nice and stiff so that they could just use a finger movement like that. So this one is intentionally rough. This one's intentionally not pretty. The idea here is to show that you don't have to have real complex maker skills to make these. So this is a Circuit Playground Express, a $25 board, again from Adafruit. I don't only use their stuff, but I use their stuff a lot. And if I plug this in, you'll see we're actually going to use several things on this board to make this work well. We're going to plug in the microcontroller right here under the Xbox XAC. And now, let me switch to this camera so you can kind of see what's going on here. All right, so now, if I take this, I literally can steer by turning it just like a, well, I'm not going to promise to be good at this game, but there we go. Anyway, so when you turn left, you turn left. When you turn right, you turn right. When you go forward, you go fast. When you go back, you stop and back up. There you go. So if I hit the this button over here, there, it will jump. Okay. And if I push this one here, it will boost. So this is basically made a 2-button plus a steering wheel controller out of a piece of cardboard and a Circuit Playground. All right, so basically it's very simple. It is just the Circuit Playground is mounted to the cardboard, and then, sorry, the game keeps playing. There you go. I just used conductive tape to run out buttons to the left and the right. These go onto 2 capacitive pads that are here on the actual device. These kind of all worked out of the box. There's no hardware changes at all. There's no soldering, and you get a pretty cool controller. You don't need this rubber tape. It just made it a little sturdier. I was worried about it ripping. Let me turn off my face camera. And then I put points here and points here because we might have a time when you actually need to have hands that are captured. Maybe somebody needs to use more elbow and shoulder motion to turn this, and they might want to put their hands inside of this grip. So I thought that that might just be a good addition. In general, this works great. It's certainly probably the best bang for the buck. It's $25 for the Circuit Playground Express, and I don't know, $1 for the tape. Less than that, 60 cents for the tape. Overall, very powerful for a $25 solution. This is based on Chris Young's Sling ring. So this actually takes in, let me get a good picture of this. All right, so this is Chris's exact design. I didn't change it at all. I did use hot glue on the back instead of tape. He used tape on his. That's the only real change. This actually goes on your hand like this, and it gives you easy access to the switches from a thumb. Chris uses that for control of his computer. If he wanted to play Xbox games, I think this would probably be an effective way for him to get access to the buttons. In this case, we have it mapped out to 6 buttons. So you've got 1, 2, 3, 4, 5, 6. And right now I have these set to A and these set to B. And I haven't figured out what to do with the other ones yet. I don't think this is a good steering device. It's more an activation device of activating the buttons. It might go really well with something like this, right? If somebody had fine motor in both hands, maybe they could steer with this one and activate things with the right. So that works great. And the only thing left on this, honestly, is that I need to switch this. I originally made this with an itsy bitsy, and I changed it to a trinket. So I have to make some very, very small changes on that. Probably something simple to show you is this. So this will be there as well. This is an InstaMorph switch. Marshall Roberts uses this at Christmas time, this exact one. We molded it to his hand. And it actually places this switch exactly where he needs it. It looks like a candy cane because he uses it at Christmas time during the Bell for Salvation Army. And so what he does is he puts this over his finger, and his grip is different than mine. So in his grip, which kind of goes like this, this puts that switch right there, right where his thumb is. And we just molded it around his finger, and it works for him. It puts this exactly where he can activate it. It's a great use of an inexpensive switch and some InstaMorph to get perfect placement. But the output is a basic switch, right? A mono switch. As I think everybody on this group would probably know at this point, the XAC has a mono switch input for every button on the Xbox controller. So if you wanted to make this the B button, the boost button for Rocket League, that would now be the boost button for Rocket League. In fact, it is. Okay? There's no microcontroller. You don't have to buy any hardware. You just plug it in, and it becomes the B button. So that right there is a great little controller for the XAC. Okay? I'm going to go a little bit farther, and I'm going to use the approach we used with Max and Ella when we used a little box I made to control their power chairs. We're going to take a tiny little chip and 2 jacks. We'll plug this one into one jack. I'm just going to go grab another switch to go into the other jack. And then, all right, so both goes forward. There you go. I might actually score on this one. I did. Look at that. So this uses the exact same approach we used with Max and Ella, where right turns right, left turns left, and both goes forward. There is no way to go reverse in this setup. That's actually a problem they have in their chairs as well. But it is a really good use of showing how a little bit of logic can take a couple basic switches and make them much more powerful. Probably just one more or two more to talk about. I talked about using a true Nintendo nunchuck. We can do that. We've got a nunchuck set up that takes a Nintendo nunchuck and outputs a mouse. Having it output a gamepad is not a significant difference. We'll be happy to help somebody if they want that. I don't think I can bring a Nintendo nunchuck into the Microsoft booth, so we're not going to spend any time getting that to work. There's one more that I want to do with the Circuit Playground, and this one isn't quite ready yet, but there's no hardware involved. So the Circuit Playground, one of the options for it is this neat case. So if you remember, the Circuit Playground looks like this, and on it, let's get a good look at this so you guys can see what's on here. So basically on here you've got 2 buttons, a temperature sensor, a light sensor, a microphone, a speaker, a orientation sensor, accelerometer, so you can tell tilting, and then a lot of these pins, in fact almost all these pins, are set up as cap touch, which is what we're using here. So you can make them work as capacitive touch. Then it's got a bunch of neopixels and a little switch that you can program. Sometimes it's kind of fragile and it's kind of open. So Adafruit actually made this neat little case that will hold the Circuit Playground exactly, and you still have access to the 2 buttons and the switch, and you can clip things onto the cap touch and everything. So on the back, it's got a 1/4-20, so you can mount it on a camera mount. It also has this neat little strap area right here where you can run a strap through it. And so the last of these things that I'll make before Saturday basically will just hold a Circuit Playground onto somebody's wrist and have a micro USB cord coming out of it. That actually gives you 2 really powerful tools just by itself, and I'll probably use this switch to switch between them. One that it has built-in tap detection, which means if you tap it, it will detect that. It can detect the acceleration of a tap, or it can detect a shake. And so either one of those could be set up as a button press, either a tap or a shake, and there's no hardware involved, and the software is pretty straightforward. So this is what I'll probably be doing in the hotel room tomorrow night or Thursday night. So that's the last one of these. It's a lot of Xbox controllers. It's kind of been a lot of fun. Kind of been a ton of work. But we are very happy with how it's turning out. The problems with the Xbox has its issues. It's an early rev. The hardware, I don't think there's anything I would change on the hardware kind of at all. The big buttons are great. It has all the things pulled out on the back, and generally speaking, it works really, really well. The USB interface has some challenges. It's really picky. You've got to make it exactly the way that it wants it, or it will ignore you. And so I actually worked to customize the CircuitPython build from Adafruit to make it accepted. I'll feed that back to Dan Halbert and those guys, and they'll work with me to make a version that works out of the box with this. I'm also working with Bryce from Microsoft to try and get them to be a little less picky about how that works. Because there are some things you can't do easily. Some of the buttons are only available on the left USB, some are only available on the right USB. There are just some limitations that I understand why they're there, but there probably are better ways to do that in a version 1.1 or something. But as far as overall, this is a huge improvement for accessibility for gaming. So kudos to Microsoft for doing it. I'm sure the people at Grip and places like that, Warrior Enabled, all those things will love it. And I'm really kind of happy that these all worked. We really haven't had any idea that we've wanted to do that we found we couldn't. The nunchuck, I didn't bother. I think everything else will be done by the end. We didn't do a sip and puff, and we could have. But let's just call that'll be version 2, unless I get really bored on Thursday night. If you guys have any questions, let me know. As far as the code for this, it's all open source. The designs will be all open source. I will probably put a custom build of CircuitPython for each of the major boards up, either on the Adafruit site in a guide or somewhere where you guys can get to it, because there will probably be a period of time where you've got to use the custom version of CircuitPython before either Microsoft or Adafruit shifts a little bit, and it's really not Adafruit's fault, right? Adafruit might put in a Microsoft-specific version of the joystick, but that would really be them working around the issues with the controller's USB ports. So until that's the case, I've got one. If anybody wants one, let me know. And I look forward to seeing some of you at ATIA. Hi, Kathy. How are you? And I will probably make... These videos didn't quite come out well enough to use them in the actual guide, so I'll probably make individual videos for them. But I thought you guys would want to know what I was up to, and I'm real happy with it. So if you're available on Saturday, come to Orlando. We do not have a snow apocalypse and a blizzard, and we're having Maker Day. It's going to be awesome. We're going to do a magic wheelchair reveal for Alex Philo. That's awesome, and it's going to be a blast. So I hope to see some of you there. We'll probably go live with that as well for the reveal, and I look forward to seeing you all then.